Hi everyone, welcome. So this is the solution video of the questions given in Telegram channel. Okay, so these are very important questions. So actually these are the questions from the standard textbooks I'm giving you on Telegram. So if you are not the member of Telegram, please go and join the Telegram so that I have given questions there. I don't want to write the questions again here. I'm going to give you the solutions only, right? So that's all. We will start. Okay. So the first question of GOC I have given: arrange the order of nucleophilicity in increasing order, right? So what is the order of nucleophilicity? So F minus, OH minus, OH minus, NH2 minus, and CH3 minus. These are the options. What is the order of nucleophilicity? Nucleophilicity is nothing but, first of all, nucleus level, right? So this is the nucleus. So nucleus loving, because nucleus has a positive charge. So these are the negative charged species. So which species will be given its electrons more easily towards this positive charge? That is nothing but nucleophilicity. So simple. Here two factors are there. So the first one is which species or which compound has less electronegativity. Okay. So first of all, the first condition is less electronegativity. Less electronegativity. Second, you have to see size. Okay, because size is always inversely proportional to the nucleophilicity. If you see fluorine, oxygen, nitrogen, carbon is more in size and less electronegative. So whenever this is less electronegative, it can donate its electrons towards positive charge more compared to the other, right? So this is less electronegative and more in size. It can donate its electrons, so that this is more nucleophilic. This is next, this is next, this is next. So order is this. Yes, this is the order of nucleophilicity. First question, ho gaya. Second question, arrange the following in order of their increasing carbonyl stretching frequencies. So the first option given like this, lactone. Okay, so the first option is given like this. Second option given this. Second option given this. Third option is something like this. This is the three-member ring. Okay, so what is the carbonyl stretching frequencies? If you see, this is sp3 oxygen atom, or if this lone pair will participate here, we can say sp2. So all oxygens are sp2, or we can say sp3, right? Okay, so in actual sense, this lone pair is participating here, so this is sp2. Okay, so now, first of all, this lone pair, this lone pair, this lone pair will participate like this, and this bond will break like this. Okay, this bond will break like this. Now, what is the carbon stretching frequency? So this double bond becomes single bond because of this resonance. Because of this resonance, double bond becomes single bond. Then I will get this structure. I will get this structure, single bond O minus, and next one is this single bond O minus. Next structure is four-membered ring, and here O minus double bond. You have to see the strain. So strain is more here, here, or here. Okay, by seeing only we can say the strain is more here, because three-membered ring is very strained ring. Okay, three-membered ring is very strained ring. And again, additionally, I am getting double bond here. So this is very strained one. This is very strained one. So whenever this is very strained one, this lone pair cannot give these electrons towards this carbonyl carbon very easily, because if this lone pair will give these electrons towards this, then I will get this. This ring is not stable. Okay, in nature, always product should be stable. If product is not stable, reaction will not move forward. So whenever this oxygen is not giving that easily to this carbonyl carbon, whenever this oxygen is not giving these electrons towards this carbonyl carbon in a very easy manner, that means I have C double bond O only here, not single bond O. That means stretching frequency is very high here in 3 compared to the 2. Okay, so again the strain is very high here, so it is not that easy to get this product compared to this. We can easily get this product because strain is less, so that here single bond nature is very high. In the product, single bond is nature is very high. When single bond is there, that means stretching frequency is less, so the order is this one. Okay, so the carbon stretching frequency is very high at 3 compared to the 2, 2 compared to 1, right? Next, third question, arrange the acidic character of the following carboxylic acids. Right? So following carboxylic acid, what is the acidic character? So first option is given this. First option is this COOH. This is the first one. Second one is this 4-membered ring. This is the 4-membered ring, and here COOH. Third option 5-membered ring. Here COOH. Here COOH. Last one is 6-membered. Last one is 6-membered ring. Okay. If you observe here, which is most acidic? What you have to see? First of all, remove this hydrogen. In every option, remove this hydrogen and see stability of the conjugate base. So here, if I remove this hydrogen, I will get minus here. I will get minus here. Minus, minus. Now you have to see which is more stable conjugate base. If it is more stable conjugate base, then that is more acidic one. Okay. Here if you see this internal angles, okay, these rings internal angles, if you see, this internal angle is 60 degrees nearly, right? Generally this is sp3 hybridization, so 109 degrees. Okay, this should be 109 degrees, but because of the ring strain, I have only 60 degrees here, 90 degrees approximately. Here 5-membered ring 108 degrees, here 120 degrees, right? So here the bond angle is comparatively, compared to the other rings, here the internal bond angle is less. That means whenever the bond angle is less, bond angle is directly proportional to the percentage of S character. Percentage of S character. So here the bond angle is less, percentage of S character is less. Whenever here the percentage of S character is less in internal side, outer side the percentage of S character is more. Outer side, outer bonds, on outer bonds, percentage of S character is more. When percentage of S character is more, it will pull electrons towards itself more, right? This bond will pull towards electrons towards itself more. So whenever it pull electrons towards itself, this negative charge can be stabilized very easily towards this electron with the drawing group compared to the others. So this is more stable conjugate base. Whenever this is more stable, this is more acidic, this is more acidic. So that's the reason why. So the order is D less than C less than B less than A. A is more acidic, then B, then C, then D. Okay, same rule is applicable on all the 4 options. Right? Next question. Next question is, yes, arrange the order of electrophilic attack for the following compounds. So the first option will be, the first option is given this here CF3, right? Here CF3. Next option here CL3, C, just wait, yes, oh, it's not writing here, just wait. Okay, this is CCl3, why it is not writing? Okay, right, CCl3. Next here CBr3. Next one is CBr3, CBr3, right? Just wait. Yeah, I'm just erasing this. Okay. Next, so CBr3. Next one is, last option is Ci3. Last option is Ci3. Okay. So now examiner is asking about the electrophilicity, order of electrophilic attack. So electrophilic attack means electrophile. So if this ring has to attack this electrophile, first of all this ring should be electron rich, right? That means this should be activated ring, not deactivating ring. Okay. Generally we think that fluorine is more electronegative, so it will pull electron towards itself because of the minus I. So this ring is more deactivating, that means positive charge will be localized on this ring. So this cannot give its electrons towards electrophile. So this is, electrophilic attack is very less here, but actually this is wrong. How you have to see? So first concept, homo-lumo. Okay, use homo-lumo concept. What is the HOMO-LUMO concept? Simply, you can understand, if the electronegativity difference between the two atoms is very, very high, the energy gap between HOMO-LUMO is very, very high. Right? That is one concept. Otherwise, simply, here second period element, here this is also second period element. So overlapping is very, very high. Bond strength is very, very high. Okay. Here this is second period, this is third period. Here second, fourth, here second, fifth. Right? So that means here this bond is very, very weak bond compared to the others. So whenever this bond is very, very weak, again here the carbon is 2.5 electronegativity, here this is 2.6 electronegativity. Okay, it will attract electrons towards itself more easily. That means this bond we can break very, very easily, so that these electrons can go to the LUMO of the carbon very easily. Right? These electrons will go to LUMO of the carbon very easily. So whenever it is happening, that means this ring is more deactivating, because positive charge will attain on this ring very easily compared to the others. That means electrophilic attack is very, very less here. Okay, same rule is applicable here. Here the bond strength is very, very high, so we cannot break this bond very easily. Okay, second, HOMO-LUMO energy gap. That means the electronegativity difference between this and this is less. So here the LUMO, if you see, these electrons cannot move to this LUMO that easily. So that's the reason why. This is more activating, this is more deactivating. So whenever this is deactivating, electrophilic attack is not at all possible here. So D less than C less than B less than A. Okay, clear? Okay, right? So if you have any doubt in this, I will explain you in my next video again in a very, very clear manner. Okay. Next one is just wait. Slide is not there. Okay, I'm just removing this. I'm sorry, because slide is not there. Okay. Okay. Next question. One question given to you. The first option, consider the following compounds. The first compound given is this, double bond O, N. Here there is a lone pair. Okay. Second option given to this, given this option given to you. Third option is this. Nitrogen is here, lone pair, and here there is a ring like this. Double bond O, and here N. Fourth option is this. pH is here. Here there is a lone pair. Here double bond O. Now the first option is the rate of alkaline hydrolysis of B is faster than that of A. Whether it is correct option or not, you have to say. Okay, so alkaline hydrolysis, that means if you take water, right? So OH minus, H plus. Okay. For suppose this lone pair is participating here, right? Then I will get this one, pH, O minus, here double bond N, here trimember ring, and I will get the positive charge here. Okay. Now again, next step is it will go back. Now here get the positive charge. Here OH minus can attack. Okay. So initially this trimember ring is very, very strained ring. Initially it is very, very strained ring already. So whenever this lone pair will participate here, strain will increase because of the double bond. So at least a fraction of seconds, this electron cannot be localized here. So immediately it will go back, and OH minus can easily attack here. That means hydrolysis is very, very faster. Actually this step is not possible, right? Because of the strained one, this step is not at all possible. Okay, but if you see, this is the lone pair is there. This is the sp3, this is the lone pair is there. So this can easily participate. And again it will go back. So hydrolysis is faster here. Hydrolysis is faster here. So this lone pair cannot participate here because this is not stable. After getting double bond, this is not stable. So this lone pair will not participate here. Will not participate here. So whenever this lone pair is not participating, hydrolysis is not possible. This lone pair can easily participate. This lone pair can easily participate and it will get back. And hydrolysis is possible here. So the rate of alkaline hydrolysis of B is faster than that of rate of alkaline hydrolysis of A. So option 1 is the correct option. Option 1 is correct option. So only thing in rate of hydrolysis you have to see. So the first one, this lone pair will activate this. Will activate this. Again it will go back. This OH minus can attack. Whether this lone pair is participating in a very easy manner or not, you have to see. Okay, here this lone pair cannot participate here because of this strain. Here this lone pair can participate, so that the rate of hydrolysis of B is very faster than A. So first option is correct option. Next, I'm really sorry, I'm just erasing instantly because I don't have slide. I forgot to generate extra slides. Okay, next one. Okay, so if you see next question, arrange the acidic character of marked protons. You have to tell acidic character of marked proton. The first option is this. The first option is this. The first option is this. Here two hydrogens are there. Okay. Second option. Second option given to you is this. This is 5-membered ring, and again here I have 6-membered ring. I have 6-membered ring. Here two hydrogens are there, and again third one, here one 6-membered ring is there. This is attached to this. Again here one 6-membered ring is there. Okay, one 6-membered ring is there like this, and again here one 6-membered ring is there. Okay, here there is hydrogen, and again last one I have this 6-membered ring, two 5-membered rings, two 5-membered rings, here 6-membered ring, here also one 6-membered ring, one 6-membered ring like this. Alright, here there is a hydrogen. First of all, you have to see which is more acidic, right? First of all, remove this hydrogen. This negative charge should be stable. If this is more stable, then this is more acidic. If you see here, this is rigid system. This is more rigid system because two 5-membered rings are there here. Here, one 5-membered ring is there. These two are rigid systems. So this negative charge can participate in delocalization very easily here because of the rigidity. So D is more acidic. D is more acidic. Then C is more acidic because of the rigidity. So here both are non-rigid, but here 6-membered rings are high. So this negative charge can be stabilized more, so that B is more acidic than A. So the answer is D, C, B, A. That means A less than A less than, whether it is options are correct. Options are correct. Yes, D is more stable. Then B is more stable, right? Here the B is more stable. Then C is more stable. Then A, right? Because of the rigidity here, rigidity is very high, so D is more stable. Then B. Then after that C, because of the 3 rings, C is more stable because delocalization is very high. Then A, so DBCA. That means A less than, C less than, B less than D. Right? Next one. I think one question is there still, right? Yeah, 2 questions are there. Just wait. 2 questions are there. Sure. Still we have 2 questions. Just wait. Okay. So first of all, the correct order of stability of the following compounds. So the first compound is given to you. Here, this is the first option. Here, this is CH2 plus, CH2 plus, and here CH3. This is the first option. Okay. If you see the carbocation stability, always you have to see mesomeric effect is greater than hyperconjugation is greater than inductive effect. Here, mesomeric or resonance effect is not there to stabilize this carbocation. So you have to see hyperconjugation. Here, 3 alpha hydrogens are there. If you see here, this is 3 alpha hydrogens. So if this bond will move like this to stable this carbocation, this bond will move like this, and this hydrogens, 3 hydrogens can participate here. So 3 alpha hydrogens are there. In second option, I have given in place of CH3, CH2 CH3. I have given CH2 CH3 in place of CH3. So here this is the alpha hydrogen. So 2 alpha hydrogens are there. 2 alpha hydrogens are there. In third option, I have given in place of CH2 CH3, I have given CH, CH3, CH3. How many alpha hydrogens are there? Only one alpha hydrogen is there. Only one alpha hydrogen is there. Okay. Fourth option. In place of this, fourth option is this. Okay. CH3, CH3, CH3. That means 0 alpha hydrogens. Right? So because of having 3 alpha hydrogens, so the first one is more stable. Next second, next third, next fourth. So option is A, B, C, D. Okay. Always you have to see hyperconjugation. Hyperconjugation is nothing but number of alpha hydrogens you have to see. Right? Okay. So next one. Last question. Last question. The correct order of basicity of the following heterocyclic compounds. So the first option given to you. Here this is nitrogen. Here double bond carbon. Here nitrogen. Hydrogen is this like this. Okay, this is the structure given to you. Second structure is this. Second structure. Here double bond. Here N. Here H. Okay, this is the second one. Third one. Third one. This is the third one. This is third one. Okay, so fourth one is this. Fourth option is this. Here H, here double bond, here there is a lone pair. Okay, first of all, you always have to remember whenever we have, in general, we have more number of heteroatoms, basicity will be very high. Compare it to this. Okay, so compare it to this. Here DCBA, first option. Here 2 heteroatoms are there. Here also 2 heteroatoms are there. So this lone pair can participate in delocalization like this. So the electron density on nitrogen will be high here. Here also the electron density will be high on nitrogen. So the basicity of this nitrogen will be very high in both the rings. But if you see here, this is sp3 hybridized one. Okay, here this is sp2 hybridized one. So percentage of s character is very high. So comparatively, it pull electrons towards itself more. So this lone pair cannot participate in delocalization in a very easy manner compared to A. So basicity of A is greater than B. Clear? Okay. So next one is, if you compare these two things, here this lone pair is participating in delocalization, and because of this ring is aromatic. So very stable ring. So this lone pair cannot give these electrons to others. So basicity is very less here. Basicity is very less here. So this is more. So what is the option? So D is very less because of aromaticity. So next one is C, because only one nitrogen and this is the sp2, right? So next C, next B, next A. So this is the basicity order. Clear? I hope you people understood this lecture in a very clear manner. Still, if you have any doubts, you can ask me in Telegram channel. Okay, so that's all. Thank you so much for watching. Okay.